The advanced capabilities of the James Webb Telescope, which include its expected to be able to see back in time to the earliest galaxies to emerge after the Big Bang, the Supreme Observatory, to provide insight into important issues regarding the beginnings and development of the universe. But more than 2 years after it began operating, the telescope managed to solve many riddles are posing significant concerns regarding the early cosmos. However, the information found on James Webb isn't just what experts anticipated, even though the breathtaking photos on the internet. Scientists working in outer space had to acknowledge that something was off. Telescope has found evidence that challenges scientists' current theories about how the universe formed and is starting to seem as though we might have to change the course of the universe's history in the place of humanity within it. Join us as we examine in detail how James Webb just destroyed our universe in 2 years. The James Webb Space Telescope is among the most sophisticated. The planning for the James Webb telescopes was initiated more than 25 years ago, and after more than 10 years of building, on December 25th, it was launched into space, 2021, and reached its ultimate target, which was 93,000 miles away, in less than a month. Earth's position in orbit provides it with a comparatively clear view of the cosmos. The telescope's design was a worldwide endeavor spearheaded by NASA with the goal of expanding the limits of astronomy. Observation. The mirror is massive, concerning revolutionary engineering. With a diameter of 6.5 m, about 3 times that of the Hubble Space Telescope that was launched in 1990 and is still operational today. Its enormous mirror, which enables it to gather light webs, enabling it to see stars and galaxies that are the faintest and furthest away. Modern devices can provide details about the composition, temperature, and motion of objects in the universe. Of these far-off cosmic objects, making the James Webb Space Telescope a valuable tool for thousands of space scientists, is a portal to that uncharted universe. How far back may the James Webb appear? A telescope peered into the universe and back in time to roughly 13.5 billion years. Does not depict exoplanets, galaxies, or stars as they are currently. Astronomers are seeing a glimpse of the past because light travels through space with a certain amount of time. Ultimately indicate that a travel is involved in looking into space with our telescopes. This was true in the past, even for objects that were rather close to us. It was illuminated by the sun around 8 minutes and 20 seconds ago. You can easily calculate how long it takes for all of the light from the sun to reach Earth in that amount of time. The speed of light in the sun, a flashlight, or a light bulb in your home is nearly 300,000. The speed of light is around 150 million km/s, or just over 18 million km/min. That translates to roughly 8 minutes and 20 seconds from Earth, but the more away the light from Proxima, the nearest star, and Tauri, the longer it takes for it to reach us, is due to something. With the exception of our sun, which is 4 years old, it is roughly 40 trillion years old. Kilometer away from Earth, meaning it takes light more than 4 years to get to us, or as. For light years is how scientists like to describe it. Most recently, James Webb observed. One of the farthest stars ever observed by telescopes is Arendelle. The Webb Space Telescope from Arendelle is approximately 12.9 billion years old, is using telescopes like the Hubble Space Telescope to look considerably further back in time than was previously feasible. Hubble, for instance, can see things 60,000 times fainter than any other telescope. The Supreme Observatory can observe nearly 9 times as many things as the human eye can, more than even Hubble can detect. But is it feasible to look back to the Big Bang is the term used by scientists to describe the beginning of the universe as we know it. Think it happened roughly 13.8 billion years ago. This is the most commonly acknowledged. The name of the theory used by physicists to describe the origins of our universe is A. However, it is a little deceptive as it implies that the cosmos was created by some kind of explosion, similar to fireworks. The appearance of rapidly expanding space everywhere in the cosmos is more accurately represented by the Big Bang theory. The universe's immediate post-Big Bang atmosphere was like a cosmic fog that shrouded it, making it difficult for light to move past it, eventually causing galaxies, stars, and planets to expand, which is why this cosmic epoch is known as the Cosmic Dark Ages. The cosmos kept expanding, cosmic mist started to clear, and light was eventually capable of unrestricted spaceflight. In reality, a few satellites have studied the remnants of the Big Bang's light. These telescopes were constructed around 380,000 years after it happened to detect the uneven remnants of the Big Bang, whose light can be seen in the microwave spectrum, but even 380,000. There were no stars or galaxies in the cosmos years after the Big Bang, but it was still a tremendously. The cosmic terrible ages would not end for several 100 million years in this terrible area. Eventually, as the first galaxies and stars formed, the James Webb Space Telescope was not intended for observations that extend back to the Big Bang, but rather to the time when the earliest objects in the before the universe started to develop and release light. There wasn't much. Given the circumstances of the early cosmos and the dearth of galaxies, there was not enough light for the James Webb Space Telescope to observe. And stars looking back in time to the moments just before the Big Bang is not only a. Astronomers have already addressed the issue of having a wider mirror by using other satellites that monitor microwave light from the immediate aftermath of the Big Bang, allowing the James Webb Space Telescope to. There is no restriction on the observation of the universe a few 100 million years after the Great Bang. Rather, that is the purpose of the telescope. It reflects the location of where in the universe we expect the researching old galaxies to see the initial light from stars and galaxies. Scientists seek to comprehend the peculiarities of the early cosmos and acquire understanding of the mechanisms that help them thrive, which covers the life cycle and the growth of extremely huge black holes, of stars, and what exoplanets, or planets outside of our solar system, are composed of. But the information from the James Webb isn't exactly what scientists had anticipated. In the argument for the 2024 Isaac Asimov Memorial, astronomer and science communicator, a conversation at the American Museum of Natural History in New York was conducted by Neil deGrasse Tyson. Scientists conversed on how information from the telescope might be changing our understanding of basic knowledge of our cosmos, ranging from differences in the universe's age to the unexpected. The James Webb Space Telescope's brightness of early galaxies has already inspired scientists to re-evaluate how the early universe functioned, potentially yielding revelations that could cause significant changes to our universe models during the course of the next 10 or more years, as James Webb's tenure and, as Speaker Michael Bowen Kuchin put it, a speculative. University of Texas at Austin astronomer, the data from the telescope presents a consistent and continuously updated image of the early universe. The issue started practically as soon as James Webb's initial glimpses of the far-off universe. Such far-off, ancient space regions were perplexing in two ways. First, there were a ton of galaxies in its pictures, much more than a few of those galaxies that astronomers once believed were feasible, seemed to be enormously large, and these were all from the first 700 million years into the universe, and their weight might reach 100 times that of. Because of what scientists believed to be feasible at the time, these galaxies were known as universe breakers. Knowledge of the universe's evolution proceeds as this initial dark matter collapsed into enormous clusters known as halos in the first few. Following the Great Bang, the halo's gravity drew in regular stuff over 1 billion years, finally forming. It would have taken time for matter to congregate into stars and galaxies. If the gigantic galaxy is real, gradually accumulating larger and larger galaxies. James Webb spied on galaxies so soon after the Big Bang, which shouldn't be conceivable. Furthermore, not nearly enough dark matter halos are predicted by the existing understanding of the universe for the early beginning, like the numerous large galaxies that the telescope observed in that. Given scientists' current view of how the universe evolved, things appear fairly bad. The example of the remarkably energetic early universe could be connected to another prominent astrophysics paradox, the age of the universe. The Hubble Space Telescope played a critical role in assisting with the scientific agreement over the age of the cosmos. In actuality, the telescope mirrors were created especially for astronomers to observe stars known as seeds. In order to determine that age, the age of the universe as a whole is measured at around. Since then, 13.7 billion years have passed, but remember that there is yet another. Using the cosmic microwave background, which contains light from the earliest stars, to calculate the age of the cosmos. Phases of the cosmos. With this technique, scientists discovered a somewhat greater value of 13.8 billion years. And while it might not seem like a big difference, nobody knows, but some estimations based on seeds put it as low as 12.8 billion years. Where the difference originates, it's as though we were excavating a tunnel on different sides of a mountain and we overlooked. Unfortunately, James Webb's image of the remarkably bright early galaxies did nothing to unravel this puzzle. In fact, LED Rajendra's findings from the telescope. In an article to be published, Gupta, an astrophysicist at the University of Ottawa, suggests that based on the new data, the age of the universe may be as high as 26.8 billion years, or roughly twice as old as present estimates. The panelists concurred that Gupta's proposal is improbable, but the difference of, generally speaking, the age of the universe supports the conventional cosmological model and our comprehension of the influence dark. To put it simply, the role that matter and dark energy play in our universe might need to be revised. What's noteworthy about our current situation is that something basic is lacking. Not only do Webb telescopes have the potential to reveal previously undiscovered galaxies, but they also keep cosmologists up at night. Double-check the Hubble Space Telescope's observations of the expansion, which were made by its older twin. Rate of the cosmos are remarkable. The groundbreaking observatory discovered sound, which increased the so-called. In plain English, Hubble tension refers to observations of the universe's expansion rate determined by a property. The Hubble constants simply don't add up based on single-hand measurements of the radiation from the cosmic microwave background, which is similar to an infant image of the universe from only 379,000 years after the. According to Big Bang Theory, the universe should be expanding at a pace of roughly 67.8 km/second per MEAP parsec, which implies that 1,000,000 times the volume of space. Parks should be growing at a speed of 67.8 kilometers per second on average. Alternatively, you can ascend the cosmic distance ladder and estimate this expansion by noting where each step is produced by distinct astrophysical milestones, such type I supernovas and Cepheid variable stars, depending on how bright they are. These objects can provide their distances, which we can then use to calculate by comparing them to their red shift valve values. The amount of expansion the universe has undergone while their light has been reaching us. But the issue is that this approach provides us with an entirely different value for the Hubble constant, which is approximately 73.2. Cosmologists believe to be the apparent paradox between the two measurements, which is kilometers per megapark, have begun referring to it as the Hubble tension. No one is certain of its cause, but some. New physics is proposed as a possible explanation for the seeming conflict, is that the cosmic distance ladder's bottom rung, which contains the seed, has a measurement inaccuracy. Variable stars are those whose luminosities varies in a predictable way as they pulse in and out over time. The greater the maximum luminosity throughout this interval, the longer the pulsation period between periods of maximum luminosity. We can measure the pulse period and determine their distances to Earth thanks to the luminosity relation. In order to determine the maximum luminance based on the brightness of a Cepheid variable. When something light seems in the sky, we can calculate its distance from us, although it's not nearly a perfect method. Cepheid variables in far-off galaxies can be observed by the Hubble Space Telescope, but the more distant, the more difficult it is to pick them out from all the other stars that swarm around them. Unresolved stars near Cepheid variables in these distant galaxies raised concerns since they may be contributing to the side's apparent brightness values, causing a systematic and invisible inaccuracy. Interstellar dust may also have an impact on the data, reducing the brightness of the seed variables from our perspective. Point on Earth, but fresh data from the James Webb Space Telescope shows that 5 galaxies are home to A. The infrared vision of James Webb has ruled out this potential inaccuracy with a combined total of more than 1,000 Cepheid variables, capable of piercing through interstellar dust and distinctly resolving the seed variables thanks to its increased resolution. As a result of this, the 5 galaxies that James Webb saw stand out from the farthest away, NGC 5468, is located 30 million light-years away from Earth, have additionally welcomed 8 type II superNEOs collectively in recent supernovas, which indicate the demise of white dwarfs, have A. They constitute the following rung on the cosmic distance ladder above the standardizable luminosity curve. Seeds because the subsequent rung needs to be calibrated based on the preceding rung. The distance measurements using Type 1 are consequently supernal based on the Webb's observations of SPI variables, NAOE, that are sufficiently luminous to be visible in far more distant galaxies than children. Precise, and they also inform us of a discrepancy in the various Hubble measurements. Constant from these measurements of the Webbs, astronomers headed by Johns Hopkins University concluded that the first observations made by Hubble were aptly described as reefs. We have now covered the entire spectrum of what Hubble found, and we can eliminate a measurement error as the reason behind the extremely high assurance that what's left is the thrilling and genuine opportunity we have misinterpreted the cosmos. We must ascertain whether we are lacking any information on how to connect in other words, the tension at the beginning of the cosmos and the present. Cosmology's core disciplines of physics and astronomy are here to stay. Beginning to feel as though there might be a serious issue. It's not just that some of us feel that in addition to changing the mainstream model of cosmology, we may need to reconsider it. The way we perceive some of the most fundamental aspects of our cosmos, a conceptual revolution that would, after all, have ramifications that go well beyond the realm of science. That our knowledge of the history and origins of our cosmos has advanced remarkably. However, it is also true that we are incredibly perplexed, particularly when it comes to the early stages of cosmic. Without a doubt, these historical instances contain amazing mysteries, possibly the secrets of a fresh scientific revolution, but our world contains its. We must work to free the secrets that are holding us back from changing them. In a recent amazing discovery, James Online, taking them from mystery into discovery, has found that the growth of early universe galaxies must have been significantly faster than expectedly. The same researchers also discovered that the universe formed 10 billion years ago wasn't quite as disorganized and tumultuous as people had previously thought. The multinational group headed by Durham University academics in the UK came to these conclusions after finding evidence of structures named star bars that were developing in galaxies that were only a few billion years old. Star bars are extended areas of enhanced star formation following the Big Bang, density present in spiral galaxies' cores, such as the Milky Way and other disk. As star bars emerge, galaxies force gas toward the centers of their respective galaxies, controlling star formation and the existence of these central bars. Structures therefore show that a galaxy has moved toward a more developed and settled phase, as Durham University researcher and Zoe Lente team leader stated in a statement. It's a great surprise that galaxies in the early universe are maturing far faster than scientists expected, since you would anticipate that the cosmos would be quite chaotic at that time, with many galaxy collisions and a great deal of gas that hasn't yet turned into stars. But because of the James Webb, using the Space Telescope, we are able to observe several of these bars at considerably earlier stages of cosmic context, indicating that galaxies were in a more developed stage of their evolution than originally believed. Thus, we'll need to change our perception of early galaxy evolution, since this isn't the first instance. In the early history of the 13.8 billion-year history of the universe, scientists have visited bars. The Hubble Space Telescope saw these same feats in the universe, but its circling eye could only date back as far as 8 to 9 billion years, yet the heightened sensitivity and James Webb's wavelength range has extended these observations back at least another billion years. Bar development in galaxies estimated to be between 8 and 11.5 billion years old has been discovered. Actually, the team took 20% of the 368-disk galaxy GES into consideration for the study. Already featured bars that were twice as many as those that Hubble saw. The researchers used James Webb to gaze back in time, and the fewer bar structures they saw in galaxies speculate that this might be the case because earlier in the cosmos, galaxies were not as well. As an alternative, consider the fact that shorter bars were more typical and increasingly earlier. Even the James Webb's remarkable observational capability is unable to detect these brief bands in galaxies. After obtaining these results, the team wishes to use the telescope to study early galaxies. Take a closer look into cosmic time. reaching back 12.2 billion years. This may have demonstrated if bar expansion was typical only 1.6 billion years ago. The Big Bang, as GDT determined, the universe's simulations now require to be closely examined to see if the findings match the observations we've made with the James Webb Space Telescope. Must go beyond our preconceived notions in order to observe the Webb in a different way. The oldest dead galaxy ever observed has been found by a telescope, yet the cosmic corpse has baffled scientists because it defies explanation based on what we now know about the early star formation in cosmos. The galaxy was abruptly and unexplainably stopped when, in the year 700 million years ago, the universe was only beginning to give birth to stars. Because there's a lot of pure gas and dust elsewhere in the galaxy called Jade's GS Z701 in the cosmos. Hugh, and explained in an article that was printed in the magazine Nature, gives astronomers providing a glimpse into the enigmatic causes of galaxy development in the early universe, such as why, when galaxies stop producing new stars, and whether the factors causing their starbursts change over epochs, according to study lead author Tobias Lucifer, a researcher at the Cav Institute at the University of Cambridge. Cambridge, or KICC galaxies, require an abundant supply of gas for cosmology to create new stars, and the early cosmos resembled an endless smorgasbord. The newfound galaxy not only took shape less than a billion years after the Big Bang, but current models are unable to explain how. Bang but also promptly closed its star factory, according to the study's co-author. It is only later in the universe that Francesco Dina, a researcher at KICC, should exist, that galaxies typically begin to show signs of ceasing to generate stars in contrast to a small number of other dead galaxies discovered elsewhere seem to have stopped producing new stars around the time the universe was roughly 3 billion years old. Lucifer and associates utilized James to find Jade's GDSZ7AQ Webb's strong infrared vision to see through the dense dust cloud obstructing the oldest living things in the universe as well as the oldest deceased or observed thus far. The newfound galaxy has also been observed frequently, lighter than other inactive galaxies discovered earlier in the early data from the universe web indicate that stars in the galaxy are intensely produced someplace between 30 million to 90 million years before it abruptly stopped. However, it's still unclear exactly when it did so. Astronomers are aware of a few distinct elements that can impede or completely stop star formation, such as turbulence, such as the radiation from a supermassive black hole inside a galaxy, can force gas out of the galaxy, depriving it of the gas reservoir necessary for the formation of further stars. One fascinating theory is that the gas was not adequately replenished by the galaxy's surrounds at the time. Deficit in star formation due to star birthing consuming reservoir material, yet as kick astronomer Roberto Molino, a co-author of the study, noted, we're not sure if any of those situations could account for the current state of Webb models as we observe them, are unable to account for the characteristics of J's GS based on the current universe. Z701 Chu indicating that they would need to reconsider alternative answer. Why the Dorsey of the new galaxy could be that early universe galaxies die and then suddenly came back to life, although earlier studies of deceased galaxies from when the universe experienced its most frequent star birth, it was about 3 billion years old, stated that dead galaxies like these cannot resurrect even through mergers with nearby galaxies. However, merely function to puff them up, as Dueno stated we'll need further observations to aid in our understanding. A brief comment: James Webb is now investigating the mysteries of gas planets in further detail. The researchers claim to have begun making progress in determining how long gas giants will probably need to grow around their host stars before all the short response is not very long, but the gas surrounding those stars fades away. The research team employed the Webb telescope to reveal a far more complex tale. Examine the somewhat ambiguously named disk wind. This doesn't really relate to the process of gas exiting a disk surrounding a star, not a wind as one may think. Would be one that is composed of several materials that have the capacity to form planets. Otherwise, described as a protoplanetary disk by Namin Bajaj, lead author of the most recent disk wind analysis, and a lunar and planetary scientist at the University of Arizona laboratory, we were aware of their existence and potential significance. We were unaware of the underlying physics of disevolution, and as a result, the answers to all of our inquiries about the amount of mass being lost depend on them. To be clear, the collision of such a disk would also contain non-gaseous debris, such as dust that can eventually combine to form stony planets. This is actually how, although Bajaj and other experts were unable to reach a definitive conclusion, Earth is thought to have originated once. Firmly established response to the question of how long gas planets might form until protoplanetary waste gas completely depletes. He did, according to Bajaj, provide a rough estimate based on his calculations. Taking into account the quantity of gas in this disk, and presuming that the gas would continue to exit at the same rate that we find one moon mass annually, roughly 100,000 will be needed. Years may seem like a long period, but as Bajaj noted, a protoplanetary disk has an extraordinarily brief lifespan in astronomical terms, lives for roughly 5 to 10 million years, even if it's overly corny too. Currently, all of information serves as evidence of how significantly the James Webb Space Telescope is transforming Undoubtedly, our grasp of the universe's infrared sensitivity is enormous. However, many of its findings are due to the corpus of work already in existence to expand the library of publications that have been assisting scientists in determining the exact location of the James Webb. That's all the information we have for you today. If you enjoyed it, don't forget to leave us a thumbs up. In order to ensure that you don't miss any next episodes, please ring the bell and subscribe to the episode if you haven't already. Tell us what you think of the stuff we've released today. Your support encourages us to keep producing high-quality content and to keep getting better as always. Thank you for watching, and see you later.